So far our ball is falling and hitting our paddle but not bouncing. So how are we going to make it bounce? Well, that's where physics materials come in. Physics has an S on the end. Unity don't seem to realise that, as you'll see. So the physics material is used to adjust friction and bouncing effects of colliding objects. Let's take a look at their documentation for it. Here we go. You see they call it physics material. You'll see that in various places. But this shows you something about physics material. So let's go to Unity and make this happen. First thing we're going to need to do is create ourselves a folder called materials. Now later we may call these type of folders physics materials because there are other types of materials like rendering materials, but for now let's just call it materials for simplicity. And in there let's create not a physics material actually, because that would be 3D. Most things are 3D by default, but a 2D, physics 2D material. So create one of those and simply call it ball, because it's the ball's material. Let's take a look at it. It's got a friction of 0.4. Well, actually we're going to set the friction to 0. We don't want the ball to have any friction. What is the friction? Well, click the blue book. The blue book will open the manual page for the physics 2D material very helpfully and tell you what the friction is, coefficient of friction for this collider. But we're not worrying about that. We're going to set that to 0. We don't need any friction on the ball, but what we do need is a bounciness. Now what's the range of bounciness? Click on the word and drag left and right. You'll see we can set it between 0 and 1. Great. If I click play now, nothing's going to happen. Why? Well, because it's all very well making a material, but we have not attached that material to the ball. So click on your ball, look under the inspector, under the Circle Collider 2D section, and you'll see that it's asking for a material. Drag the ball on there. Now let's play. Boing, boing. Cool. Now look how high the ball is bouncing. It's bouncing up to exactly the same point every time. It has something called a coefficient of restitution, which is the bounciness, of 1. That means that it's perfectly bouncy. We're also seeing another interesting fact here. You see the ball is slightly interfering with the background. That's because the ball and the background are at exactly the same depth, and they're actually perfectly coincident with each other. I'd like to push the background down a little bit to stop that effect before exploring this bouncing a little further. So go back into your scene view. Now just for a moment, click 2D for me and make it 3D. And then it'll spin around. I'm not sure exactly the orientation you'll have. You can use the right mouse button to change. But just look, the camera is over here. So if you move around, I'm holding my middle mouse button down now, and then use the right mouse button to manipulate your position. You'll get the idea that we have a camera over here, and then we have a background at a Z depth of 0, and a ball also at a Z depth of 0. So why don't we push the background back a little bit? Just give it a Z depth of just say 1 world unit. Okay, so it's behind the ball now. You'll find that when we play now, the ball will just look that much more clear, and it won't interfere with the background so much. And that's because it's now in front of the background. All right, so we've just pushed the background away a tiny bit so it doesn't interfere with the ball. Great. So back over in the scene view, let's take a look at the effect of changing the bounciness now on the ball. So what is this bounciness figure firstly? Click the blue book. It'll take you back to Unity's manual page here. And it tells you that the bounciness is the degree to which collisions rebound from the surface. Value of 0 indicates no bounce, whereas a value of 1 indicates a perfect bounce with no loss of energy. Okay, so said differently, I've got a slide here that explains exactly the same thing. 0, no energy conserved in the collision, which is what, well, let's see that happening. If we set a bounciness of 0, the game needs to be not running when you do this, by the way. Watch what happens. No kinetic energy is conserved in that collision. Okay, and then the next thing it says is that a value of 1 means 100% of the energy is conserved in the collision. Well, we've seen that happening. So it starts off with no kinetic energy. You'll probably remember this from school. And it has a certain amount of gravitational potential energy relative to the paddle. And then as the game runs, that kinetic energy is converted from the gravitational potential energy, and it keeps bouncing to the same height. So that's what it means by all of the energy is conserved. It'll never decay, the bouncing. Now, the question is, what would happen if I set the bounciness to 0.5? If it leaves the paddle with half the energy it hit, then because kinetic energy is a half mv squared, it's going to be going up to only 1/4 of its height. So If you want it to bounce to half the height, you're going to need to take the square root of the height you want it to bounce to each bounce. So if you want it to bounce to 0.5 of its previous height, you're going to need 0.707 roughly. Let's try that. Bounciness of 0.707. If that maths is right, then it'll bounce to about here in the middle of the guy's chest on that triangle. Let's try, expecting it to bounce to here, and it does, you see? Every time it bounces to half the height. In our game, of course, we want the ball to continue bouncing forever. So we want a bounciness of 1 in our case. So don't worry about the details of choosing bounciness. I just wanted to show you how you would get a bounciness that you want if you wanted to. Now, if you do want to know more about the physics, of course, then pop over to my little face here, take a look at the other courses I've got. One of them is Game Physics, Extend Unity 3D's physics engine. And in there, I'm going to take you through step by step how to build your own physics engine, and you'll be in a much better position to understand things like how this thing bounces, how high it bounces, how energy is conserved, etc. So take a look at Game Physics 101. It's a course I'm really passionate about. I've really enjoyed putting it together, and the feedback that I'm getting already is really cool on it. So here we go. Let's try the bounciness of 1 again, and it will just keep bouncing, which is precisely what we want here. We want energy to be conserved whenever the ball hits anything. So congratulations, we have a ball bouncing on a paddle. It's a bit more visible, the ball now. And I shall see you shortly.